Hi, we are from Group Big Potato from the HPDP class section 2, and I'm Paula E. So now our group will be presenting the project 2 with the title of Shopee Application Real-Time Sentiment Analysis by using the Apache Spark and the Kafka. Right, nowadays, the Shopee Malaysia receives thousands of the customer reviews through the Google Play Store, and these reviews provide a valuable feedback on the user shopping experience, application performance, payment services, and also the overall customer satisfaction. However, as the number of reviews continues to grow, so it's manually analyzing each review has become inefficient and also time-consuming stuff. So, in addition, the traditional sentiment analysis is also commonly performed using the batch processing, where these reviews are analyzed only after they have been collected. So, this has limited ability to monitor the customer opinions in a timely manner. So, therefore, our project has proposed a real-time sentiment analysis pipeline that automatically collects, pre-processes, and also classifies the customer reviews by using the NLP, Apache Kafka, and also the Apache Spark by enabling the faster and more efficient customer sentiment monitoring. For this project, we have 6 objectives that we want to achieve. So for the first, we want to collect the Shopee Malaysia review from the Google Play, while for the next, we want to build a streaming pipeline by using Kafka and Spark. For next, we want to perform the MLP pre-processing on our data. Well, next, we want to visualize the result using the Elasticsearch result. And for the fifth, we want to train and compare the sentiment models. While lastly, we want to compare the batch and also the streaming performance by in the end of this project. Now, I will be presenting the data collection, which is the first part of our project. For the data collection process, we use the Google Play Store as our data source with using the Shopee Malaysia application because it contains the public customer reviews and ratings from real Malaysian users. So to collect the reviews, we use the Google Play scraper in the Python. So first, we verify the application package name, which is the com.shopee.my, to make sure that we are collecting the reviews from the correct application. So then, the scraper uses the pagination to continuously retrieve more reviews pages, and this process keep repeating until we successfully collected 10,000 reviews at all. So during the collection process, we extracted only the metadata that we needed, such as the review ID, rating, review date, app version, thumbs up count, and also the original review text. So finally, the collected reviews were saved into a CSV file containing the 10,000 records with 6 attributes inside. And this has become the raw data set for the data pre-processing stage later. From here, we can see that this is the raw data we get from the Google Play Store Shopee application review. So we store it inside the CSV file, and this is the attribute we get. So from here, we also can see the description for each attribute and also their example. After getting the raw data, now we will proceed to the data processing part, which we process the data into the usable format so that it can able for the later analysis. So for this data pre-processing stage, so it consists of 2 parts, which the first part is data cleaning, followed by the NLP pre-processing part. So during the data cleaning stage, the duplicate, missing, and empty reviews will be removed, and also the reviews that containing less than 3 words will also remove together to improve the overall data quality. So as a result, the dataset was reduced from 10,000 rows to 6,395 rows. So next, the NLP pre-processing was performed. So the review text was converted to a lowercase, followed by the text cleaning to remove the URLs, punctuation, emojis, and also the numbers. So the text was then tokenized into the individual words. The English and Malay stop words were removed, and also the English lemmatization was applied together. So finally, a new clean text column was generated while preserving the original review text for the future reference. So the final clean dataset contains of 3,385 reviews and also 7 columns. So it will be used as the input for both the sentiment model training and also the Kafka streaming pipeline later. This is the final clean data set that we get, and from the table here we can see that the number 1 until number 6 is same as the raw data we get on the first stage, and the number 7 clean text is the new generated column, which represents the review after the NLP pre-processing. And for the clean data, it consists of 7 attributes, and this is what we get from this stage.
Hi, I'm Cheryl. So now I'll present the sentiment model development phase of Project 2. So in this phase, our primary objective was to build and evaluate the machine learning pipeline that can efficiently categorize Shopee application review into positive, negative, and the neutral sentiments. Okay, so now we're moving to our model development setup. So to find the best performing algorithm for the high dimension text data, we developed and experimented with 3 distinct linear and the probabilistic framework. So first, we established the multinomial net bias as our baseline model, configured with a Laplace smoothing alpha 0.1 to handle the potential zero probability issue in unseen vocabulary. So second, we trained a logistic regression model using the L2 regularization with a penalty parameter c equals to 0.5. And third, we deploy a linear support vector machine, linear SVM, and also applying a regularization constant c equals to 0.5 to optimize the classification margin. So crucially, because our Shopee review dataset exhibit a significant class imbalance, so with the positive review being the heavy majority, and we explicitly integrate the class weight balance parameter into both the logistic regression and the linear SVM pipeline. And this penalty modification forced the model to give the proper attention to the minority classes, particularly the underrepresented neutral feedback. Next is our model comparison. So if we evaluate all the three fully trained model against an independent test data sets of 1,279 samples. Because of our skill data distribution, so we relies heavily on the weak F1 score as our primary comparative benchmark. So as highlighted by the star symbol, multinomial net bias emerged as the overall winner, achieved the highest accuracy at 88.19% and the top weight F1 score of 0.8663. So while the linear SVM managed to secure a slightly higher macro F1 score of 0.64, indicating the marginally better class by class equity, and we ultimately finalized the multinomial net bias as our best model selected. Aside from the delivering the strongest overall predictive accuracy, net bias operates on a lightweight and probabilistic architecture. So this gives it an incredibly low inference latency and low computational overheat, making it the perfect processing engine to embed in our downstream Apache Spark structured streaming pipeline. And this selection ensures that our live Power BI dashboard can refresh smoothly without the accounting pipeline bottleneck. And that's all for my part. Thank you.
Okay, so now I will talk about the overall Apache system architecture. The process starts from Shopee Malaysia Google Play reviews. After the data is collected and cleaned, the clean review dataset becomes the input for the real-time pipeline. And in this architecture, the Apache Kafka is used as the messaging layer. It receives the clean review data from the Kafka producer and store the message in a topic called sentiment topic. Then the Apache Spark act as the processing layer. The Apache Spark reads the incoming message from Apache Kafka and applies the trend sentiment classification model previously to predict the sentiment of each review. And after the prediction is generated, the output is stored in two places. The streaming result is saved as streaming prediction.csv files, and the prediction record are also stored in Elasticsearch. And Kibana is used to validate and monitor the index streaming records, while the Power BI is used for dashboard analysis and comparison. So this architecture shows how the system connects the data ingestion, real-time processing, storage, visualization in one complete pipeline. So for the implementation, my part focused on building the real-time pipeline using Kafka, Spark Structure Streaming, and Elasticsearch. And first, the Python Kafka producer reads the clean review data row by row, and each review is converted into JSON format and sent to the Kafka topic. This shows how the new customer reviews can enter the system continuously. Next, the Spark Structure Streaming consumes the message from the Kafka and processes them in micro batches. The trend sentiment model is applied to the clean text field to predict whether each review is negative, neutral, or positive. Finally, the prediction results are saved into streaming prediction.csv files and also stored in Elasticsearch under the sentiment predictions index. And the stored output is then used for Kibana validations and Power BI dashboard analysis.
So now I'll proceed to the visualization part where I have used both Power BI and also Kibana for the dashboard. So let's look into it. Now this slide presents the batch processing analysis using Power BI. So a total of 6,395 Shopee reviews were analyzed, and the model achieved is about 92 accuracy with about 5,000 correct predictions. So based on the donut chart, positive sentiment was the largest category, and while the neutral sentiment was the most difficult to classify, there's only about 1%. And the second dashboard actually allows us to filter the correct and incorrect predictions for the end user, and it also inspects the individual review details if they need to view. So now this slide shows the streaming results visualized using the Kibana. So a total of 60 streaming messages were used, consisting of 70% of positive and 30% of negative prediction. So actually no neutral sentiment was predicted because the neutral class was too little and very difficult for the model to identify. So we can see there's only 1, 3, and 5 review rating that consists of only positive and also negative reviews. So next, the timestamp chart also confirms that the Spark processed the incoming Kafka messages in several micro batches instead of a line. Now in this slide, the first slide actually summarizes the streaming analysis using the Power BI dashboard, and the second one is the comparison between streaming and batch processing. So the streaming accuracy was about 95% compared to the batch processing, which is 92.13%. So there's actually only 3% difference between them. So both models produce mainly positive sentiment based on the orange-yellow column chart at the right side. So however, there's a limitation, which is the streaming result should be interpreted more carefully because it was calculated using a much more smaller sample than the batch processing. It takes only 60 messages from the overall around 6,000 messages reviewed. Now I'll talk about some optimization, limitation, and also improvement that could be made for our future project. So for the comparison, batch processing used about 6,000 reviews and achieved 92% of accuracy, while streaming achieved 95% accuracy using only 20 unique reviews across a total of 60 messages. So therefore, the streaming result is slightly higher, but it is less reliable because of the smaller sample size compared to the batch processing. So for the model optimization, a more neutral review should be collected where class balancing techniques could be applied onto it. So a stronger model such as logistic regression, linear SVM, or BRT could also be used. So next, for architecture optimization, a larger streaming sample of course should be used, and Kafka partitions and Spark micro batch settings could also be improved together with the checkpointing, error handling, and also monitoring the whole process. Overall, batch is better for the full model evaluation, while the streaming is better for the real-time review processing.
So that's all from our group. Thanks.